Well, hello my dear students, how are you all? Welcome to day 27 of our series PU to Brahmastra. I hope all of you are doing good. Today's chapter of discussion is linear programming, a very simple chapter. If you learn the concept with all the clarity, I'm very sure you can solve this question for sure coming in your examination for PU2 boards, right? So we'll see the weightage, how the chapter is going to be, we'll see the important definitions, we'll see all of that. But before, I want you to come up and give us in the comment section that whatever we are doing, sir, in this series is going very good for us. Everything is working out. Any other feedback that you have, you let me know in the comment section. We'll try to come up with the solutions for your queries, for your problems, right? That's what we do over this platform of Diksha Karnataka, right? Anything that you have, let us know in the comment section. We'll try to come up with a solution for all of you to help you achieve your goal of getting centum, getting very good marks in mathematics for PU2 boards, right? So let me start with the session, bacha. Starting over here. Check it out. So if you look at the weightage, you have again only one question coming in this according to your latest blueprint, 6 marker, one question, high weightage, simple questions. We will certainly get it done, sir, right? Again, important announcement for all of you who are here for PU2 boards examination. So what is this going on, sir? To complete your preparation, to ensure that you are 100% there for your preparation for your PU2 boards, we at Diksha has come up for your for that problem solution which is what, a test series only for PU2 board students, a unique test series named as Success Blueprint Test Series for PU2 boards. Okay, what is this unique, what is the unique thing about this test series? So we'll talk about the features. So first of all, in this test series you're going to get 12 mock test papers. Out of the 12 mock test papers, you will have 4 part test papers which will have physics, chemistry, maths in it. Okay, means it will be PCM in the first 4 test papers, which will be based upon a part syllabus. Okay, you will get the syllabus once you join our once you enroll and join our group as that. And next 8 session will be 8 mock will be on full length, full syllabus subject wide test. Okay, I hope this is clear. Next, what we're going to do, so what you're going to get from us after purchase of this test series, first thing you're going to get obviously some mock test papers, the PDF solutions, also the video solutions of the test papers. Very important, video solutions you're going to get, sir, at the same, this is a pack where you're going to get all these things, right? Video solutions, and most important thing, you're going to get the doubt clarification classes for your mock test series. So very important, right? That's why it is unique. You'll not find a session like this, a test series like this available right now for you of this good quality, and all of this can be availed at a price of $599 only right now. This is for the prices right now that is going on. Once you go into the 3rd week of December, 2nd week of December, you might find these prices higher, and I know that you will come back and get this later because you'll feel that, okay, that yes sir, I'm not sure with where we are right now in the preparation. I've given a test in the exam in the school, in the PU college, but still I feel that if I could go give more exams, okay, if I could revise better, get my doubts cleared, then I will feel more confident going in the examination. So don't wait for the last minute to purchase this test series. Purchase it right away. The first test, the first part test goes live on the date of 15th December. Means for all of you who have purchased this test series, don't worry, you'll get this test series live for you on our platform at 15th December. Details have been shared with you. Okay, if you are not able to get all the details, let us know in the comment section. We'll let you have all the details, either mail it to you or something like that. We'll reach out to you, no problem. Okay, so great sir, I hope this is clear. Moving on to our session. First of all, let's look at the session plan. So what we have, first we're gonna discuss some important definition. How come, sir? Because this chapter is completely theoretical if you see that way, or it is completely graphical. Only 2 ways to ask questions in this chapter. So theory we'll also see. Again, we'll see question. I've taken total of question 20 questions I've taken, bacha. Okay, again all PYQs only. Okay, some questions I've taken MCQ because your PYQ doesn't have those many MCQs. So I wanted to solve some MCQs. That's why I've taken some MCQs from HOTS category or some normal MCQs. Okay, so total 9 MCQs I've taken. Great sir. 10 to 15 I've taken 2 marker PYQs, and last 6 to 20 I've taken 6 marker PYQs. Total of 5 questions. I hope this is clear. Okay, 6 marks weightage. That's why I've taken more of 6 marks question. I'll solve it, all of it for you. Okay, and I'll give you one also as a homework. Define the following in LPP. In linear programming, let's define some terms. First one, linear programming problem. Okay, linear programming problem, what we call this? So the problem in which we have to optimize the linear function. Linear function means what, sir? It means x plus y, means the power, the degree has to be always 1. Whenever we are asked to optimize, what's the meaning of optimize, sir? Whether maximizing or minimizing. Okay, so whenever we are asked to do that, okay, this function is called as z. Have a look. This objective function This linear function is also called as objective function. Z subject to certain conditions called as constraints, right? What are the conditions called as constraint? Is this whole situation is called as linear programming problem. Means whenever we ask to optimize a linear function subject to some constraint or some conditions, it's called as linear programming problem. Linear constraint is what, sir? Those linear inequations, right, that we use to, identify our feasible reason. Correct? Now we'll talk about everything, but try to understand this. Those form of linear inequation that we use, okay? So the limitations on the resources what we are using to identify the feasible reason can often be expressed in the form of linear inequations, which is known as linear constraints. These conditions, right, this is same as constraints. Moving on, objective function. A linear function, this part, a linear function involved variables, correct na, x, y, which we want to maximize or minimize. Check na, sir. Optimization can be done in two ways, maximizing or minimizing. Example, profit can be maximized, costing, our expenses can be minimized, right? If the function is to make more money for any production house, that's how we can do it. Subject to the given linear constraints, same thing, right? The conditions is known as objective function. Simple as that. Very important, when they are asked in examination, you have to write a very good statement. So you have to practice these statements over and over again. How can you do that? I hope you have joined the WhatsApp channel. If you have not, join the WhatsApp channel and get the class notes delivered to you. Okay, everything will be delivered to you, whatever we are dealing with, whatever the sessions are going on for all subjects, all the class notes PDF will be given to you. So please join the WhatsApp channel. Chali. Decision variables. The variables involved in the LPP are called decision variables, right? So variables in LPP is a set of quantities to be determined, x and y, right? Those variables. In the problem of optimization, constraint set. The set of points satisfying the constraint of an LPP is said to be constraint set of LPP. The points that is satisfying the constraints, correct na? Those inequations. Constraint means what? The inequations that we talked about. Optimal value, the maximum minimum value, means what is the end goal. After optimizing, we find the maximum value or minimum value. That value is called as optimal value. What is that called as? Optimal value. Means once you find out the feasible reason, you look for that one particular value where the function is maximum or minimum, right? That value is called as optimal value. Okay, moving on, have a look. Feasible reason. Feasible reason, a common reason determined by all the constraints, all the linear inequations that is given to you. Once you plot them on a graph, you get a intersection of all that reason, right? And that is called as your feasible reason, right? So the common reason determined by all the constraints, including non-negative constraints. What is that, sir? X and y both positive. Correct, na? Means first quadrant, x greater than 0 is above x-axis, above on the right of y-axis, and y greater than 0 is above x-axis. Correct? All of you agree? Great, sir. Is called as feasible reason. Feasible solution, the points, the solutions, the coordinates in the feasible reason is called as feasible solution. A set of values of the variables x and y, in where? In the feasible reason. In the feasible reason, they've not mentioned it here, but yeah, in the feasible reason is called as, we satisfy the constraints, means those values of the variables which satisfy the constraints, basically what? Basically are present in the feasible reason is called as feasible solution, sir. In feasible solution, just opposite of that, right, which does not satisfy the feasible reason, or which is out of the feasible reason or does not satisfy the constraints given to us, linear inequations given to us, is called as infeasible solution. Okay, optimal solution, those maximum minimum values, right? Correct. Great, sir. Feasible solution which leads to the optimal value. Optimal means what? Either maximum or minimum value. That feasible solution is called as optimal solution. How many feasible solution can be there? If I ask you, how many feasible solution can be there? Many, right? It can have, if you check a, let's say, graph like this, if I take this, all of this area, how many solutions will be there? Infinite number of solutions. A lot of points are there. Which point satisfies or gives me the question that is asked, maximize or minimize? That point will be called as maximum solution, and that is nothing but our optimal solution. Clear, right? Okay, sir. Corner point, wherever you have these intersections, whenever you have what, the straight line going through the 2 points or the corner of the feasible solution, corner point of a feasible region, है ना, is the point in which region which is intersection of the two boundary, correct na? Two lines going like this, let's say one boundary is this, other boundary is this. I can take another example, a boundary like this, a boundary like this. So this will be a corner point. What is this boundary of the feasible region na sir? Boundary of the feasible region, right sir? Yes. So that is called as corner point. Okay, optimization techniques. Again, we can use what? Two type of optimization technique, whether it can be a maximization or minimization. Please check. The process of obtaining the optimal value of a system of inequations are called as optimization techniques. Okay, chali. Please remember these definitions, very very important. Moving on to the first question, let us solve it. So quickly we'll solve those 20 questions. Very very simple. I want to show you the trend of the questions also in these PYQs. Have a look. So this is not a PYQ. Every point of a feasible region is called what? Alright, this is from definition only, sir. Feasible solution, sir. Every point, I said na, for a feasible region you'll have a infinite number of feasible solutions. Agreed? Great, sir. So feasible solution is correct. Okay, bacha party. The feasible region in LPP is always what? Alright, this is convex. Correct, na? Right? Okay, no problem there. Okay, a very standard question. This can be asked. Very good question. Okay, simple but it can be asked. Please remember a couple of things. Corner points of a feasible region determined by following system of linear inequalities. Okay, given like that: 2x plus y less than 10, x plus 3y less than 15, where x, y, x and okay, the non-negative the constraints are 0, 0, 5, 0. These are what, bacha? What are these values? These are the corner points, sir. What is this, sir? The corner points, sir. These are the corner points, sir. Great. And what is this, sir? Objective function, sir. What is this, sir? Objective function. Clarity hai? Is that clear? Great, sir. Where P and Q are both positive or non-negative, condition on P and Q so that maximum of Z occurs. They're saying these two are point of maxima. They have told in the question from their side the point 3, 4 and 0, 5 are the point of maxima. Okay, so let's apply that. So again, is it the point of these points are from the corner points? Please check. 3, 4, 0, 5. 3, 4 and 0, 5 is the corner point. Excellent. Please check. So right here corner points are what, bacha? 3, 4 and what is this, bacha? 0, 5. Is it visible? Okay, let me write it from this way. What's the Z value? So Z value is simply Px plus Qy. Substitute the P value over here. I get 3P plus 4Q. Same you do for 0 and 5. This is not 6 and 5. This is 0 and 5. Have a look. In 1 second. This is 0 and 5. Okay, put 0 here, bacha. So simply 0 plus 5Q. Correct, na? QY, right? So y is 5, so 5Q. They're saying both are maximum. What are these 2 points? These are both, bacha, Z maxima, right? Z max, they are both of the values are conditions on P and Q so that the maximum occurs at these 2 points, means both these values are maxima value. Okay, so they have to be what, bacha? They have to be equal, na? Please equate it. Bring this over here. What you're getting, sir? You're getting 3P equals 5Q minus 4Q, which is simply Q. Option number 4 or D. Q equals to 3P. Q equals to 3P. Option number D is correct. Can a question get simpler than this? Of course not. Can a chapter get simpler than this? Of course not, sir. A very simple chapter. Moving on to question number 4. Okay. Corner points of a feasible region are, again, corner points are given to you. Z is given, so objective function is given here, bacha. Where P and Q, again non-negative, no problem. Condition on P and Q so that maximum. Same question, similar question. Okay, so let's solve it. Again, what is happening, bacha? Maxima is there. Please check. Okay, so if you check it out here, let's write the corner points first. These 2 points are having the maxima, so let's write it down. 15, 15, the first one. Great, sir. What is this going to be, bacha? Z value is simply, sir, Px plus Qy. Px plus Qy. Excellent. So please check. 15x plus 15y. And how much is this? Okay, it's 0, 20, not 20, 20. My mistake. Okay, so I get what? Simply here 0 and 20y. This is q bacha. Okay, these two both are z max only, so equate them. 20y, bring it out over here. I get 15x equals to what, sir? 20 minus 15 is simply 5. So 5y, cancel it. I get, okay, 1 second, it's not x. It is not x. I wrote an x everywhere, no? It's p and q, right? It is 15p, 15q, q, 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 p, p and q, right? Correct, no? X and y values are we are substituting, no? So 15p and 15q over here to 0p and 20q. Clear? Okay, they equal, so like that. And if you take this 5 3s are, I'm getting q equals to again what? 3p. Option number, please check option number C. Q equals to 3p. Option number C is correct. Moving on to question number 5. Corner points of the feasible reason. I'll not solve this, I'll give you as homework. You have to solve from your side. Let me know the answer in the comment section. I will give you the answer, of course, but you must solve it from your side. Same question, right? Constraints are given. The corner point is like this. Okay, this is your objective function. Yes, sir. They have said that minimum is occurring at the points over here. Right, means find the objective function's value or z minimum for both the points in terms of p and q. Once you do that, equate them to each other because both of them are minima. In that case, you're going to get the answer to be option number B. Have a look. Okay, please let me know. Okay, so solve and comment your answer. Comment your answer. What's the answer, sir? If you're getting B, what is the right? Right, sir? GIR. Got it right, sir. Moving on. I hope that's clear, right? Same question. Question number 6. Fifth and fourth are same. Fifth, 3 and 4th are same. Sixth one. Corner points of a feasible reason for an LPP are 0, 2, 3, 0, 6, 0, 6, 8, 0, 5. Let z equals to 4x plus 6y be objective function. Then minimum of value of z occurs at. Please check. So I'll write this corner points again over here, and this I'll write it as my objective function over here. Have a look. CP is what, sir? O2. So 0, 2, 3, 0. Okay. 1 second. 6, 0. Last one is 6, 8. One more is there, sir. 0, 5. 0, 5. What's z values? Please check here. Z is, sir, 4x plus 6y. Okay, put it here. So 0 plus 6 into 2 is 12. Okay, 3 into 4 is again 12 and plus 0. This is 0 plus 2 and this is 12 plus 0. Please check. 0 into 4 is 0, right? 2 into 6 is 12, right? Great. Now over here 3 into 4 is 12, right? And 0 into 6 is 0, right? What about this? 6 into 4, 24. Okay, so over here 6 again will be more only, these two values will be higher only. Please check. These two are higher values. Okay, so I'm looking for what value? Minimum value, means over here. So both of these are 12 and 12. So this is what? My z minimum value. Z minimum value. So basically what is my answer? Only can't be true. Both of them are having the same condition. We can write what? Any point on the line segment joining the points 0, 2 and 3, 0. So option number D. Right now, any points lining the points, any points lining the joining the points where the minima is occurring. Two corner points. Let's say this is the point 0, 2, and what is that? 3, 0. Then the line joining these two will be what? All these points. Infinite number of points will be there. At all these points, you'll have a minima value. Clear hai? Clear hai? Okay, sir. Okay, sir. Moving on, bacha. Moving on, sir. Question number 7. Simple. Which of the following is false? Okay, very important to know this. We are looking for false statements. If m is largest value, maxima, and small m is the smallest value, the least value, for objective function given like this, okay, we are not looking for any values. All variables are there, so we have to just understand the statement. First one, if feasible reason is bounded by, okay, bounded, yeah, if feasible reason is bounded, then m will be maximum because it's the largest value. Correct, na? m is the largest value and you have a bounded feasible reason, then m will be maximum. So this is also true. This is, sir, true, sir. Great. If feasible reason is bounded, m is minimum value. Correct, na, sir? If you already have m as smallest value and it is bounded, means limitation is there. Good, sir. That is the, can you have a smaller value than m? You can't have, right? This is smallest value. As a bounded reason, it means it will be the minimum value. Correct, na? Okay. If feasible reason is unbounded and plane determined by ax plus by greater than m, okay, no common point with this feasible reason, then m is the maximum value. No common point, sir. Please check. No common point, sir. Then obviously you'll have what? Means the feasible reason is separate from the what do you call your unbounded area. For that reason, what you'll have? Correct, na? M will be maximum only. M will be the maximum only, right? Correct. Okay. Great, sir. It means what? Yeah, even C is true. C is also true, na, sir? C is also true. Let's check the last one. If feasible reason is unbounded and plane determined by this ax plus by less than m, smallest value, has common points with feasible reason, then m, it will not be minimum, na, sir, because they have common points, sir. Hai na? This is false, bacha. This is false, sir. Answer is D, sir. Please cross check. Please cross check. Okay, please cross check. Moving on to question number 8. The corner points of the feasible reason determined by the system of linear constraints are, they've given the corner point, the maximum value they're asking. Have a look. So what are the points we have? 0, 0, z is equals to 4x plus y. Okay, they're asking for maximum value, not the where the point of maxima is there. Okay, so I can't take 0. What about this? 0, 50. A will be simply 50, so z value will be what, bacha? 50 here. Please check. What about the next one? 30, 0. How much is that, sir? Z will be 30 into 4, so 120 plus 0. Last one is what? 20, 30, right? 20, 30. How much is that, sir? Z will be 80 plus 30, right? Oh, this is again less. 110. What's the maximum value, sir? Maximum value is 120. Option number D. Maximum value is what, sir? 120, na? They're not asking the point of maximum. They're asking the maximum value of the objective function. Maximum value of the objective function, which is coming as 120. Hence, the option number D is the correct answer. Moving on to question number 9. In a linear programming problem, the objective, again, this is a PYQ, right? This also was a PYQ, sir. Please check. March 2023 paper. March 2023 paper and May 2023 paper. Both are PYQs. So in a linear programming problem, the objective function is always, this is a definition only, right? This is a definition, right? Option C is correct. Linear function. Objective function is what? Always a linear function. Zx plus z equals to 4x plus 5y, ax plus by. All of the condition is always linear function, sir. Always linear function, sir. That's why we call this to be a linear programming problem. Okay. Define feasible reason in all linear programming problem. So the area enclosed due to the constraints, whatever the inequations that you had, once you plot those inequations, the area is enclosed, whatever the area enclosed by that is called as feasible reason. March 2023 paper, a PYQ. Okay, I'm not writing the answer because I've already given the definition to you. I'm not writing the answers for all these definition based questions because I've already given the definitions for you. Please go ahead, check the definition from the notes. Okay, how to download the notes? From the WhatsApp channel, so please check it out. Definition is given, sir. Okay, question number 11. Again, you can see optimal solution, May 2023 paper. What did it, bacha? Again, definition. I'll tell you the answer. What is optimal solution, sir? That feasible solution which gives me optimal value. That feasible solution which helps me go to what? Optimal value. Value of what, sir? Optimal value of Z is called as optimal solution. Correct, na? What's the feasible solution? All the points in the feasible reason. All the points in the feasible reason is called as optimal solution, and that solution, that particular solution which will give me the optimal value of the Z is called as my optimal solution given in your definition. Please have a look. You can see again repeated the same question, feasible reason. Please check it out. The repetition is there, sir. Definition, March 2023 paper. 13 questions. Define optimal solution in linear programming problems. Again, you can see is there, sir. So you can check the questions have been repeated so many times. Again, repetition. Please check, bacha. These two are, I think, the favorite question of the board. Keep asking them. Okay. Define optimal. Again, same things. July 2017. Same thing have been asked, sir. Again. Okay. Now moving on to your 6 marker category. So these were 2 marker category I've taken. Okay. Now 6 marker category, which is the most important part, because as per your blueprint, these questions can be expected. And again, these are all PYQs only. Last 5 questions, all PYQs. Have a look. So maximize z equal to 3x plus 2y. Okay, we'll see that later. Right now, let's go to the constraints. Constraints are 3x plus 2y equal to less than 10. X plus 2y less than 10. Let's write the equation form of that. So x plus 2y equal to 10. First constraint defines the next constraint, sir. 3x plus y. Can you plot this first? Let's make our work easier. X plus 2y. X is 0. Put here. X as 0. X as 0. X as 0. 2y is 10. This is 0. 2y is 10 means y is 5. X is 0 means y axis. Y is 5 somewhere over here. Please check. 0, 5. How come, sir? X is 0. 2y equal to 10. Y equal to 5. Clear hai? Clear, right? Okay, sir. Y is 0 now. Y is 0. Y is 0. X is 10, sir. Over here. Y is 0. X is 10, sir. Y is 0. X is 10, sir. Okay. Chaliye. Clear? What's the equation of this line? Let's name it. X plus 2y equals to 10. I'm looking for less than condition, greater than. Okay, less than condition. So means below this. Below this. Okay. Chaliye. Next is what? 3x plus. First one is done. Second one. Please check. 3x plus y less than 15. Acha, one more thing. I am doing it directly, but you have to do it how? I'll show you for this particular in constraint. 3x plus y less than 15. So put here, bacha. So first thing is what? Remove the inequality and write a equation over here. Now put x as 0. Put here x as 0. What are going to get? Y as simply 15. Simply what next time? Put y as 0. You're gonna get what? 3x equals to 15. So how much is that? X equals to 5. X equals to 5. So what is that? Please check. First one is what? X0, Y15. X0, Y15 somewhere here, sir. And X0, Y15 is here, na, sir? Correct. Next is what? X5, Y0. Somewhere here, na, sir? X is 5, Y0. Have a look. The line looks like this. What is this line called? This line equation is this one. 3x plus y equal to 15. Where is this? The area what we're looking for. Greater than this, right? Okay, this also is less than, huh? Please check. Okay, this also is less than. So over here, sir. Again, less than only. Below this, right? Okay. Again, what non-negative constraints are like this? It means only first quadrant we have to take. So please check this. This is my feasible reason, right? Below both the curves is this my feasible reason. I need the coordinate point. So what I have with the coordinate points? This is 0, 0 over here. Second is over here. Third is over here. Correct now? 0, 0, 5, 0 and 0, 5. I miss only one of it over here. Please check. How can I find it? By solving the 2 equations, sir. 2 equations, sir. Okay, sir. Have a look, sir. What are the equations, bacha? I can find the x value from here. Please check first equation. X is simply what, sir? 10 minus 2. How come, sir? Bring this 2y over this side, no, sir. X equals to 10 minus 2y. Simple. Put it in the second equation over here. Please check, sir. Check, Madi, sir. X is what, sir? 10 minus 2y plus y equals to 15, na, sir. So 30 minus 6y plus y equals to 15, na, sir. Okay. How much is that, sir? Bring it here. So 30 minus 15. And how much is that? Minus 6y plus y. Minus 5y. Bring on the other side, this whole thing. What am I going to get? Simply plus 5y sir plus 5y. How come sir? Minus 6y plus y is minus 5y, bring on the other side, plus 5y. How much is that? 15 over here bacha. This is 5y. What I'm getting y as simply 3 sir. Y is simply 3 sir. Y is 3, put it here. 2 into 3. Hurry. Y is 3 na? 5y is 15. Y equals to 50 by 5, so 3. Put here 3, 6. What is x na sir? X is 10 minus 6 sir. So x is 4 na sir. X is what sir? X is 4 sir. X is 4 sir, y is 3. The point coordinate is what? 4 comma 3. 4 comma 3. Is this the end of the question? No sir, they are asking us to maximize sir. You forgot. I did not forget. Maximize it. Please write the coordinate point. CP you write first the coordinate points. What was it? First is 0 comma 0. Second is 5 comma 0. Okay, first let's write 0 comma 5, 5 comma 0, and one is 4 comma 3. Have a look. 0 comma 0, 5 comma 0, 0 comma 5, and 4 comma 3. I got it right sir. Yes sir. Z value is what bacha? Z value is 3x plus 2y. Please check. Z is 3x plus 2y. 3x plus 2y. Great. Have a look. Put here 0. Put here 0 plus 10. Put here 15 plus 0. Put here 12 plus 6. 3 into 4 is 12 and 3 into 2 is 6. 4 3s are 12, 3 2s are 6. 5 into 3 is 15, 0 into 2 is 0, 0 into 0, 0 into 3 is 0, and 5 into 2 is 10. Answer is what? This is going to be my 18 value, which is nothing but Z maxima. Answer for the question that we were looking for is this: the maximized Z value, the maximized optimization. Okay, the maximized optimal function or the objective function is what? 18 sir. Have a look sir. Maximize Z for the PYQ May 2023. We are getting the answer to be 18. Have a look. Graph part is clear. How did we plot the graph is clear. How we got the corner point is clear. Any doubt, let me know in the comment section. Chaliye. Okay. Simple. Have a look. Okay, great. CP is done. 17th problem. Moving on to 17th problem. Previous questions, maximum value is coming as 18. Okay, solve it and cross check. Minimize Z equals to minus 3x plus 4y. Objective function. Subject to constraints. Our friend. Constraints our friend now sir. So again a PYQ March 2023 paper. Please check x plus 2y. How did that constraint sir? In linear form. What form sir? In equation? No sir, equation will write na. Let's write equation. X plus 2y equals to 8. Great sir. What we do? This time I don't have to write the x0 y0. I'll write directly. You will all agree. Please check. X0 y4. X0 2y is 8, so y is 4. X0 y4 over here sir. X0 y4 clear hai? Okay sir. Y0 x8 sir. Line is like this sir. Write the equation sir. So this is nothing but x plus 2y equals to 8. We're looking for less than sir, so we'll go down sir, like this. Correct na? The nature is down. Okay, 3x plus 2y. Next one, 3x plus 2y less than 12. We write in equation sir? We write directly equation na sir. Put here x0 2y 12 means y 6. Somewhere here 0 comma 6. How come sir? X0, this whole thing is 0. 2y is 12 means y is 6. Okay, this time y0 3x is 12. Y0 3x is 12 means x is 4. Please join them. Again, what is the condition? Sir, below only sir, less than. Okay, by the graphical method, non-negative constraints, first quadrant. Okay, please check the section that we're looking for. Feasible reason is this only. We have the points. Okay, we have the constraint points 0 4 4 0 0 0 and this point Okay, we have to solve it to get it. Let's solve it over here. Both the equations, subtract them. 2y 2y is there na, subtract them. One of the constraint, second constraint, subtract them bacha. Have a look. Minus minus minus, sign change I'm doing. X minus 3x is minus 2x. 2y 2y gone, so plus 0. And 8 minus 12 is how much, sir? Minus 4, sir. X is how much, sir? 2, sir. How come? Minus 2x is minus 4 means x is 2, sir. Put it here. First one, 2 plus 2y is 8, sir. So 2y is 6, sir. Y is 3, na, sir. Cross check. 2 plus 3 into 2 is 8. 3 into 2, 6. 2 into 3, 6, 12. Agreed, sir. What point is this, sir? X is 2 and y is 3, sir. Y is 3, sir. What we're looking to find out? Minimum value, sir. So what is our goal, sir? Write the corner points. Z points are 0, 0, 4, 0, 2, 3 and what? 0, 4. Did I miss something? Please check. No, I have not. Great. Principal reason is clear, right? Corner points are clear, right? Okay. Chaliye. Z is 3x minus 3x plus 4y. Z is what? Minus 3x plus 4y. Okay. We are looking for minimum value. Let's find the minimum value. 0. Okay, great. What about this? Minus 12 plus 0. Correct, na? 3 into minus 4 is minus 12 plus 0. What about this? 2 into minus 3, so minus 6 plus 12. 3 into 4 is 12, okay. And 0 into minus 3 is again what? 0 into minus 3 is what, bacha? Please check. 0 plus 16. Okay, plus 16. Have a look. So your minimum value is coming simply to be this, sir. Z minima is, sir, 4, 0, 4, 0, which is at bacha what? Which is at the point, okay, no, Z minimum is what, sir? It is not 4, 0, it is minus 12, na? And at what? At 4, 0. My answer is this. Have a look. Moving on. Clear hai? Okay, sir. Have a look from the beginning. Got it how I plotted the graph? Okay. Got it how I got this feature to plot the graph? All the corner points and then getting the maximum value. Sorry, the minimum value. Forgive me. The minimum value. Minimize. So minimum value. Moving on to question number 18. Minimize z equals to 5x plus 10y subject to the constraints x plus 2y, x, okay, less than 120, okay, x plus y greater than 60, x minus 2y greater than 0, okay, by graphical method. Chaliye, of course graphical method, sir. So we'll look for what? We'll look for first thing is constraint. Our good friend is constraint. Let's check it out. First one, x plus 2y equals to 120, sir. X is 0, y is, please check, x is 0, y is 60, 2 into y is 120, so x is 0, y is 60, point somewhere here, please check, 0, 60, clear hai? This case you have to take a good scale, bacha, because 60 is coming na, so take 1 centimeter as 10, something like that you can take, okay? You have to take a good scale, or 20 also you can take, your choice. Now, take y0, x is 120, take y0, x is 120, over here. Y0, x is 120. Join this line. What's the equation? X plus 2y equals to 120, and this is going to be what? Less than, so line is like this. Okay. Next one, x plus y greater than 60. Okay. So what is the point? Please check here. Second one, x plus y equals to 60. All right. Equal to 60. All right. Yes. X0, y is 60. So same point, sir. Okay. And y0, x is 60. Somewhere over here, bacha. Please check. 1 second. Somewhere over here, bacha. X0, y 60. Y0, x 60. So means over here, 60, 0. The point is like this. The line is like this. Have a look. What is the line's equation? X plus y equals 60. Where is it? Greater than. So up. Okay, and what, x minus 2y greater than 0, this one also is there, na? Please check, please check. So x minus 2y, I write it as equal to 0. Okay, please check. So if I take this point, if I take x as 0, bacha, y is 0. Okay, so I will not get another point like this. Let me take x as 60. So first point is what? First point is this one only, na sir? First point is this only. Please check. 0 comma 0. How come, sir? Put x as 0, y as 0. Whole thing will be 0 only, no? So this satisfies. This is a line going through the origin. Clear, right? Okay. What about the other one? Put x as 60. So if you put x as 60, what will happen? So it will become 2y equals to 60, right? So y equals to 30. Y equals to 30. Okay. So one more thing. Let me check if it satisfies the equation over here also. If I put 60 over here, if I put x as 60 in the this equation, 60. Put here 60. Please check. In this equation, I'm putting x as 60, bacha. Okay. I'm gonna get what? Please check. I'm gonna get this as 60 plus 2 times of y equals to 120. So what is that coming as? 2y equals to 120 minus 60. How much I'm getting? Y equals to 60 by 2. Simply what? 30, na? Same point is that, right? X is 60, y is 30. Over here also, x is 60, y is 30. Which means this point 60, 30 will lie on this line. Somewhere here. Please check. Somewhere over here. What is this line? X minus 2y equals to 0. And what is this point? This point is x 60, y 30. X 60, y 30. We're looking for what? Greater than. Okay? Greater than. Please check. Greater than does not. I think it should be less than, right? Okay. Okay, but if I can take that side, it will be like this only. Okay. 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 Have a look. If I bring this on this side, no? It will be y 2y less than x, right? So y when y is less than x by 2, there is going to be this condition only, right? So it will be below. It will be below, sir. Have a look. Please cross check. Please cross check this. It should be below only. It should be below only. Have a look. Yes, right? So my feasible solution should look like this. How come, sir? How come, sir? Have a look. Below this line, the yellow line, which is 2x plus 2y equal to 120, above this line x plus y equals 60, in the first quadrant, and below this line, which is going to be x plus 2y equal to 0. Okay, this is a feasible solution. Have a look. So this is correct, right? So what are the corner points? We have only one point missing over here. Correct now? This point. Please check. This point is missing, sir. So let's identify that. We'll find the minimum value then. So 60, 0, 220, 0, 60, 30, and what about this point, sir? So take the solution of this equation x minus 2y and this one x plus y equals 60, right? From here, what I'm getting? Please check. From here, I'm getting x equals to 2y. Hena, put it here in this equation. X plus y equals 60 value, not degree, sir. X plus 2y is 0. X plus y is 60. Put it here. X plus 2y. 2y plus y equals 60, sir. So 3y is 60 means 3y is 60 means what? It means y is 20. Y is 20. Please have a look. Y is 20 na bacha. So y is 20 and what is x value? 40, right? 40, 60. Please check. 40 plus 20 is 60. So what is that point? This point is coming as one second. This point is coming as x is 40, comma 20, right? Comma 20. So let me write the corner points quickly. Corner points is coming as 40, comma 20. Have a look. Next is what? 60, comma 0. Okay. Next is what? 120, comma 0. So right here. 120, comma 0. What is next? It's going to be 60, comma 30. 60, comma 30. This is corner point. We're looking for the z value. What is the z given as? Z is given as, please check, 5x plus 10y. 5x plus 10y. Have a look. What I'm getting the z values for this one. So 5 into 40 is what? 200. Correct na? 5 into 4 is 20, so 200, and 20 plus times 3 is again 200, so this is 400, sir. This one, 6 into 5 is 300, plus 0, how much is that, sir? 300, sir. 120 is 0, means 600 plus 0, so how much is that coming, sir? 600. 60 and 30, so again what is I'm getting? 300 for 60, and plus 300, I'm getting what again? 600, sir. Correct na? Yes, sir. Yeah, please check. So what I'm looking for optimization? Minimize, right? Minimize. Have a look. So minimum value is what, sir? This is my minimum value. Z minimum is simply what? 300. Have a look. Please have a look. Yeah. So we're looking for minimum value. Answer is Z minimum is 100. Okay. Please check. Yes. Yes, sir. Great. So starting from here, getting the answer looks a little messy. Please have a look. To get the fourth corner point, I did this calculation over here using the equation what? X, this one. X plus y equals 60 and x minus 2y equals to 0. Okay, clear hai? Chaliye. Moving on, have the corner points like this. We have the question number 19, minimize and maximize both. Okay, 600x plus 400y subject to the constraints like this. What are we gonna do, sir? Again, March 2017 paper, please check. Constraint number 1, x plus 2y less than 12. X plus 2y less than equal to 12. Okay, we don't need the inequality sign, sir. Only equal to will do. First one. Okay, x is 0, sir. Y is 6. X is 0, sir. 2y 12 na, so 6, sir. Somewhere over here. Correct na? X is 0, y is 6, sir. When y is 0, x is 12, sir. Please check. Y is 0, x is 12, sir. The line is like this. 1 second, doesn't pass through, it doesn't look like a straight line. I'll just redraw it. Okay, I'll try to draw better than this. Okay, this is what line? X plus 2y equals to 12. Next one is what? 2x plus y is less than 12. Okay, next is what? 2x plus y is equal to 12. Take x as 0, y is 12. X as 0, second one. X as 0, y is 12. X as 0, y is 12. Okay, somewhere over here. X as 0, so 0 comma 12 I can write, bacha. Please have a look. I can write what, sir? 0 comma 12. X is 0, y is 12. No problem, sir. Y is 0, x is 6. Y is 0, 2x is 12 means x is 6. So 6 comma 0. Please have a look. What is this equation? 2x plus y equal to 12, sir. Equal to 12, sir. Great. The last one is 4x plus 5y greater than 20. Please check. 4x plus 5y equal to 20 I can write. Take here x0. I'll repeat. x0 5 by 20. Correct na? x0 5 by 20 means y is 4. Please check. X is 0 means this thing is gone. 5y means what? 5y will be 5 into 4, which will make it 20. So y is 4, sir. When x is 0, y is 4, sir. I'll repeat. X is 0, y is 4, sir. When y is 0, x is 5, sir. Because when y is 0 means 4x is 20. So 5, sir. When y is 0, over here, bacha. Please check. I have x is 5, sir. So 5 comma 0 somewhere over here. Please check. The line goes like this. Okay. Chaliye. What is this line? This line is 4x. Okay. 1 second. I'll just redraw this line with a different ink. Please just give me 1 second. Okay. Okay. This equation is going to be what, bacha? This equation is going to be 4x plus 5 by 4x plus 5y equals to 20. Equals to 20. Great, sir. Not visible. Not visible, sir. I understand. 1 second. 1 second. Yeah. 4x plus 5y is 20. Now it's visible somewhat. Agreed? Okay. So we're looking for, let's look at the constraints, equation by equation. First one, x plus 2y less than 12. Where is x plus 2y, sir? X plus 2y is this one, sir. Less than, na? So this way, down, sir. Okay. Next is what? What is that? 2x plus y less than 12, sir. This one, again down, sir. Okay, great. Last one is what, sir? 4x plus 5y less than 20, sir. Okay. Okay, greater than 20. Not less than, greater than 20. It means above this, right? Okay, above this. Correct, na? Above this. Means my reason will be this, na? Please check. How come, sir? Below the green line, the 2x plus y equal to 12 line, below the yellow line and above this white line, which is 4x plus 5y greater is equals to 20. Correct? And obviously in the first quadrant, non-negative constraints is there. So coordinate point that we are missing, have a look. This we have 5, 0, this we have 6, 0. This is 0, 4 and 0, 6. We are missing only this coordinate point, which we can get from the yellow lines equation and the green lines equation. And what is that? Have a look. Yellow line is coming as x plus 2y equals to 12, and the green line is 2x plus y equals to 12. Let's do one thing, multiply over here simply with 2. I'm going to get what? Please check. I'm going to get this as 4x plus 2y equal to 24. Okay, and write this thing over here again. So x plus 2y equal to 12. Correct? Okay, let's do the subtraction now. Subtraction here. This is gone. I have what? 3x equals to 12 left. So x is simply 4. Okay, how is it possible? Okay, x is simply 4, means somewhat this point will come towards this. It'll be over here. Doesn't look like it, but it will come over here. And what is going to be y value? Please check. So 3x equals to 12, right? So x will be correct now. So put x as 4 in the equation. 4 if you put here. So y is going to be again 4, sir. Y also 4, sir. This point coordinate will be what, bacha? So please check. It will be 4, 4. So the figure is little bit skewed. So you have to take this point over here, and it should come towards this point. Okay, in line with this over here. This point should be somewhat. I'll show you. Should be somewhat over here. Correct, na? This point should be somewhat over here. Please have a look. This, sir, somewhat over here, but it's not the case. Accept this value. I know it's not visible, so I'll just erase this part. Okay, yeah, so I'm saying this point will be somewhat over here. This 4, 4. Okay, doesn't look like a perfect line, but accept it, sir. This is my perfect reason, feasible reason. So I have the coordinate points now. Let me write it over here first. Coordinate points and z value. First coordinate point is what, sir? 5, 0, 6, 0. First two coordinate point is 5, 0 and 6, 0. And next is what, sir? Please check. 1 second. Next is what, sir? 4, 4. Okay. 4, 4. I have what? 6, 0. No, 0, 6 and 0, 4. 0, 6 and 0, 4 on the y-axis. Correct, now? Please check. 0, 4, 0, 6. So I have 1, 2, 3, 4, 5. Na? 1, 2, 3, 4, 5. So 0, 6, 0, 4, 5, 0, 6, 0 and 4, 4. Correct? 1, 2, 3, 4, 5. Correct. Z value is what? Please check the Z value. 600x and 400y. 600x plus 400y. Right? Please check. Objective function is defined like this. So let's have a look for the values. I'm gonna get what? 6 into 5 is 30. So 30 means 3000. Rest is 0. So this is as it is. Next what, bacha? 6 into 6 is what, sir? 36. Again what? 100 only, 3600. Correct. Next what, sir? 4 into 4. 4 and 4 is there. So we have to use both. So I get what? 2400 for this one. 6 into 4 is 2400 and 400 into 4. So plus 1600. How much is that, sir? Please check. It's 4000, right? 4000, no problem. 0, 4, sir, will be 0 plus 1600. So again what? Simply 1600. 0, 6, sir. So it will be bacha simply 0 plus 2400. Simply how much is it? Is 2400. Now we're looking for minimum and maximum both values. How come, sir? Have a look. Minimize and maximize. So Z minimum is what, sir? This is Z minimum value. Please check. And what is Z maximum, sir? Over here. This is Z max value. Z max value is coming at 4,4. Minimum is coming at 0,4. So Z max I'll write here. Z max is simply what? 4000. Coming at the coordinate of 4,4. And Z minimum is simply what? 1600. Coming at what, bacha? 0,4. Have a look. Clear? Simple? Yes? Okay. Have a look once. So over here, please check from the beginning. Yes, I have taken the three equations and the form of equations to get the points. Looks messy. Please draw it neatly. Okay, I've tried to draw it neat as much as possible from my side. This is a feasible reason. As I said, this point will be over here, skewed, bacha. This point is not over here because how come, sir? 5 is here means how can it be 4? It's incorrect. So if you draw properly on the graph, no, this point 4 will come towards before 5, or this 5 will be actually over here. Getting it? Getting my point? This is inaccurate. This point will be moving towards it. I don't like it what I did, but please accept it. Okay, please draw it accurately. And the points coordinate of is what? 4,4. Have a look. I hope this is all visible to you, and this as well. Okay, answer is minima and maxima is written over here. Have a look. Moving on to question number 20. Same question you can see here. March 2016. I've solved this question somewhere here, right? March 2019. Minimize they've asked here, and there they've asked, and maximize. So solve for maximum. Solve it. Steps remain same. For the coordinate point, what you have to do? Just maximize it also. Okay, got it? Yes. So please have a look. So this is it, bacha. I hope you have enjoyed the session. I hope this was clear to you. I hope you learned and you are clear with your linear programming. Okay, as I said, to complete your preparation, we are here with a test series, PU2 Success Blueprint test series. Please purchase it at a price of only $5.99. What you're getting in this, a total of 12 mock test papers. First 4 will be a part test paper having PCM as syllabus, physics, chemistry, maths. Last 8 will be a full length test papers for subject wise. Okay, next what schedule will be said to you once you join the once you purchase and join the what's the group of ours for this students that you all have already have enrolled with us. So okay, one more thing. What are you going to get in this entire series? First thing is mock test papers, mock test solutions in the PDF format. Also, video solutions of the test papers. One more thing, doubt clarification classes. So very unique test series that is available for all of you PU2 students. Please enroll it and please get this advantage at a price of only $5.99. I hope you enjoyed the session. Okay, I hope this was fun for you. Simple chapter, 6 marks is done, sir. Very good, sir. I'm happy. I'll move on to the next chapter. Great. That's what we are here for, bacha. The most expected questions from the PYQs and your NCRT, I'm coming up here to solve for you in the PU2 Brahmastra Series. I hope you are liking the sessions. Please, be with us, support us. I'll see you in the next session. Till then, take care. Bye-bye.